Welcome to How to Study for the ACT and SAT Math, Curses Foiled Again, or How I Learned to Stop Worrying and Love Binomials. FOIL stands for First, Outer, Inner, Last. It's merely an application of the distributive property. You don't really need to remember that. Just remember FOIL, First, Outer, Inner, Last. When you multiply binomials, there's one way that's always beautiful. It's a method called FOIL. All right, but enough singing. Let's take x plus 3 times x plus 4, for example. We have x plus 3 times x plus 4. First, we take the first. Yay, that's why it's called first. X times x is x squared. So I put a little f here so we can see this is the product of the first two terms, x squared. Then we have the outer, so that's x, and 4, so that's 4 times x, or 4x. So those are the outer terms. That's why I put an O there. Inner is 3 times x. 3x is going to be I, the inner terms. And then 3 times 4 is 12. Those are the last terms, so L is 12. So FOIL. Obviously, these things in brackets, those are just notes for you to see where the first, outer, inner, and last terms went. And then we can combine the two terms in the middle, the outer and the inner, because they're both factors of x. So you can just add the coefficients. 4 plus 3 is 7. And since they're x, you can add them together. So you get 7x. So it's x squared plus 7x plus 12. Next problem. X plus 5 times x minus 6. Okay, first term is x times x, which is x squared. Outer terms, it's going to be x times minus 6, which is minus 6x. Inner is 5 times x, which is 5x. And then 5 times negative 6 are the last terms. It's negative 30. We combine the negative 6 and the 5x, so we end up with x squared minus x minus 30. Pretty easy, right? Now, what if the x's have coefficients in front of them? So we have 3x plus 5 times 5x minus 4. Well, 3x times 5x is 15x squared. And then 3x times negative 4 is negative 12x. Then the inner terms, 5 times 5x is 25x, and 5 times negative 4 is negative 20. So we end up with 15x squared, because 3 times 5 is 15, x times x is x squared. And then negative 12 plus 25 is the same as 25 minus 12, which is positive 13. And then the negative 20 on the end from the 5 times negative 4. So it's 15x squared plus 13x minus 20. Pretty easy, right? Okay. X minus 3 times 7x plus 4. Okay, then we get 7x squared. Then x times 4 is going to be 4x. Negative 3 times 7x is negative 21x. Negative 3 times 4 is negative 12. So you end up with 7x squared minus 17x minus 12. So notice that for any two binomials, ax plus b and cx plus d, you just end up with the first is going to be a times c x squared. So it's acx squared. Then ax times d, so that's going to be adx. And then you're going to end up with b times cx for the inner term, so that's bcx. And then b times d, which are going to be the last terms. So you can always write it as acx squared plus ad plus bcx plus bd, if you wanted to do this in the general form. This last fact is going to be really helpful when you want to use reverse FOIL, which is better known as factoring. Binomials you should memorize. A plus b squared is going to be equal to a plus b times a plus b, which is a squared plus ab plus b squared. Where that comes from is, of course, the first terms are a, so that becomes a squared. The outer terms are ab, so that becomes ab. The inner terms are ba, which, of course, you can just reverse and make ab. And then b squared is the product of the last two terms, so you end up with a squared plus 2ab plus b squared. A minus b squared is almost the same thing, because the first two terms are again a, so a times a is a squared. Then the outer is going to be a times minus b, so that becomes minus ab. Remember, a positive times a negative is negative. Then the inner term is minus b times a, which becomes minus ba, which we can just write as minus ab. ab and ba are going to be the same thing by the commutative property. And then negative b times negative b is going to be positive b squared. Remember, a negative times a negative is positive. So a squared minus 2ab plus b squared is going to be the product of a minus b squared. So how does that help us? Well, one thing you can do is you can take a plus b squared and add it to a minus b squared, and notice that you end up with a squared plus ab plus b squared, a squared minus ab minus b squared. So you have a squared plus 2ab plus b squared on the top from a plus b squared, and then a squared minus 2ab plus b squared, and you can line them up and add them up. And notice you end up with a squared plus a squared is 2a squared, and then b squared plus b squared is going to be 2b squared, and the positive 2ab and negative 2ab, when you add them together, they become 0 because you're subtracting the exact amount from the exact amount. So, negative 2ab plus 2ab is going to just be equal to 0. And you may have seen that I skipped this. A plus b times a minus b is equal to a squared, and then minus ab plus ab, and then plus b squared, which just becomes a squared minus b squared because the negative ab and positive ab cancel out just as they did here. That's called the difference of squares. We'll talk about that in just a second. But one important thing you need to know is these formulas will not be given to you on the test, whether it's the ACT or the SAT or any other standardized test that I know of. So know them. Notice that the last binomial is called the difference of squares, as I just said. That is literally one number squared minus another number squared. Both tests, especially the SAT, have a number of questions that involve the difference of squares because it's easy to make questions that are hard, even impossible, if you don't know the difference of squares, but are pretty easy if you do know the difference of squares. So know it. It's an easy trick that they like to use to separate the wheat from the chaff, so to speak, or how to have people who are otherwise good at math score lower than people who do know that trick. So who cares about the difference of squares? Well, hopefully you do. It's always on the SAT and the ACT. Here's the difference of squares again. A plus b times a minus b equals a squared minus ab plus b squared, which is just a squared minus b squared. So just remember a plus b times a minus b is equal to a squared minus b squared. And as I said before, the binomial above is called the difference of squares. That is, it's literally one number squared minus another number squared. A lot of times the first number is going to actually be a variable. And they'll give you something on the SAT or ACT that's going to look something like x squared minus a perfect square, such as x squared minus 9. So then you just know that it's going to be x minus the root and x plus it. So you'd say, oh, okay, x squared minus 9, sorry about the line wrap here, so it's x squared minus 9, that should be all one term, is going to be x plus 3 times x minus 3, for example. The difference of squares is in a circle. So knowing binomial squares makes it easier to solve quadratic equations by completing the square, which allows us to solve problems involving the general equation for a circle on a coordinate grid, which is x minus h squared plus y minus k squared equals r squared, where h comma k is going to be the coordinates of the center of the circle, and r is the radius of the circle. So here are a couple diagrams showing it. Here's r is the radius, hk is the center, and xy is going to be any of these values on the circle. It's going to be the same distance because it's a radius. So in this other one, they show you more explicitly that this is derived from the Pythagorean theorem. Here they're using a and b instead of h and k for the general formula of the circle. You don't see that very often, but still you can see, okay, so this is going to be x minus a. That's going to be the horizontal aspect side of this right triangle. And then y minus b is going to be the vertical side of it. So then you end up with r, the radius. And obviously, r squared is going to be equal to x minus a squared plus y minus b squared, just as in the Pythagorean theorem. Again, they use a and b instead of h and k. That's unusual. That's not standard. But the SAT and the ACT, especially the SAT, are not above doing that, where they'll just give you different variables instead of the ones that you probably learned in class to see if you can handle that. So just know how they relate, and it won't throw you if they use different variables, and you'll avoid stupid arguments like right before I took the New York State Regents exam for algebra, where I was saying, oh, a squared plus b squared equals c squared, and some kid said, nuh-uh, it's a squared plus b squared equals h squared, or vice versa. I don't know. I realized, oh, okay, I'm not going to engage with this kid. But I'm talking about it more than 30 years later, so here we go. Anyway, reverse FOIL, also called factoring. ax plus b times cx plus d. All right, we know that that's equal to acx squared, because ax times cx, that's first, plus adx is the outer, plus bcx is the inner, and then bd is the last. So it's equal to acx squared plus ad plus bc in parentheses, because we factored those out, times x plus bd. So I told you that it was going to be really helpful when you wanted to use reverse FOIL, which is better known as factoring. So let's look at an example. Factor, or reverse FOIL, x squared plus 18x plus 80. Okay, we can see that 18x, we know it's AD plus BC, and that BD is 80. So in other words, what we're looking for are two numbers that add up to, that is, their sum is 18, and multiply to 80. So let's try 16 and 2. Well, their sum is 18. Their product, oh, it's only 32. Okay, well, wait a minute. What about 10 and 8? Okay, well, 10 plus 8 is 18. And hey, 10 times 8 is 80. That works. And a quick way to make sure you factored something correctly is just to use FOIL on your answer. If you FOIL the answer and you don't get the problem that you started with, you know you did it wrong. So let's try. Okay, x times x is x squared. Great. Plus 8x, okay, plus 10x, plus 80. All right, that's x squared plus 18x plus 80. Woohoo! All right, we are rocking like docking. Another 30-plus-year-old cultural reference. Anyway, okay, so the ACT and SAT will give you problems something like this. There'll be several FOIL problems. Most of them will be pretty straightforward, but some of them will be something like this, which is pretty hard to do if you don't know how FOIL really works, if you don't know, maybe I just need to FOIL this out rather than trying to use some other way to solve it. So here we have a rectangle where this is x plus 2, and this other side is x plus 4, and they're telling you the area is 21. And now they want you to figure out the area of the second rectangle where the sides are both x plus 3, so it's really a square. So this one you might say, well, you might just say, I don't know. You're going to try all sorts of things. You'll try using different ways to solve it. But the easiest way to do it is just literally multiply this out. So here we go. We take x plus 2 times x plus 4. So we get x squared, and then 4x, and then 2x. Okay, so that becomes x squared plus 6x, and 2 times 4 is 8. So x squared plus 6x plus 8 is equal to 21. Okay, so then we could just FOIL this out and we'll go, hey, x plus 3 times x plus 3. Okay, so we know that's going to be x squared plus 3x plus 3x. That's just x squared plus 6x plus 9, or if you just memorize those binomials that I asked you to memorize, you'll just know that right away. So x squared plus 6x plus 9. So we know that the first one is x squared plus 6x plus 8 equals 21. Hey, x squared plus 6x plus 9, that's just one more. You just add 1 to x squared plus 6x plus 8. So it's 22. Darn, that was really quick. Another way you could do it is you can solve x squared plus 6x plus 8 equals 21, which means x squared plus 6x minus 13 equals 0. And then you can actually use completing the square. So you can say, all right, x squared plus 6x plus 9 would be the complete square of x plus 3. X plus 3 is 22, so x plus 3 times x plus 3 is equal to 22. And I've seen problems like this that are even harder to do, where there's literally no way to do it within the time constraints you have other than just knowing, hey, if I FOIL this and I FOIL this, oh, this is just one more than that. I get it. I just add 1 to 21 or whatever the number was. So that's why you should really understand FOIL. Would you like to help me make more videos without spending your money? Well, please like this video and subscribe to this channel. Neither action costs you anything. It takes you literally a few seconds. Worst thing that happens is once in a while, Google is going to email you and say, hey, here's something that's new on this channel. And you'll be alerted about my new videos. Also click on the little notification bell. It's usually up in the upper left-hand corner near where the Mo Money guys are here. And why do I care? It's simple. YouTube doesn't let me share ad revenues unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. If you see an ad on any of my videos, please know that I'm not getting any of the money from the ad. And while many people are watching these, I don't have 4,000 hours of watch time quite yet. And I still don't have anywhere near 1,000 subscribers, although I've been getting a lot more lately. For the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc., as long as you credit me for creating the video, etc. And I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. You know, the people that we call trolls or things that are off topic. No, I don't want to hear about your Ray-Ban site, and no, I don't want to hear about why I should wear a hat made of aluminum foil to protect me from aliens and things like that. You know, please leave that on your own channel. Anyway, thanks for watching. Have a good day.